Hello, my name is Nushin. Today I'll be going over two topics covered in my chosen scene: sound and waves, and special relativity. First, I will play the two clips from the scene I chose.
Don't!
The journey into the wormhole. The crew finally arrives near Saturn and prepares to enter the wormhole. To their surprise, the wormhole appears to be a solid 3D sphere instead of a flat circle. The crew starts to feel strong vibrations as they approach the wormhole, and the spacecraft begins to shake more aggressively. As you can see in the picture provided, when Brad reaches her hand out to where the curved wall of the wormhole, her movement appears slowed and stretched, which Cooper describes as distorted spacetime. Analyzing the physics, what we investigated for sound and waves are the intense vibrations realistic for a spacecraft. For special relativity, is Brand's slowed stretched motion realistic based on time dilation? Sound and waves, physics of vibrations. As the Endurance enters the wormhole, the spacecraft begins shaking aggressively. These vibrations travel to the structure as mechanical waves. Assumptions. NASA vibration shows spacecraft can vibrate up to 50 Hz. The speed of sound in the spacecraft is 340 meters per second. The shaking velocity is 60 meters per second. Formulas. The wavelength of the vibration is speed divided by the frequency and represents the distance between repeating points in the wave. The period is the time it takes to complete one vibration and is equal to 1 divided by frequency. Solving the vibration problem. Step 1. Wavelength. Using the wavelength formula, the spacecraft's vibration is 6.8 meters. This large wavelength makes sense for a large structure. Step 2. Period. The vibration period is 0.02 seconds, meaning the spacecraft shakes 50 times per second, which is extremely fast. Are these results realistic? Yes and no. The frequency is realistic. Spacecraft can vibrate between 20 to 80 Hz, and the movie's 50 Hz fits real NASA tested values, but the intensity shown in the movie is exaggerated. Vibrations that strong could damage equipment or pose a risk to the crew. A more realistic version would show a noticeable shaking without reaching destructive levels. Filmmakers could highlight alarms or sound effects rather than extreme physical shaking. Special relativity, time dilation. When Brad reaches her hand toward the curved wall of the wormhole, her movement appears slowed. This relates to time dilation, which occurs when objects move close to the speed of light. Assumptions. The spacecraft travels at 0.85 c, which Kip Thorne confirmed is appropriate for the scene. The crew feels 10 seconds inside the wormhole. Observers outside experience more than 10 seconds. In the second diagram, the outside observers see the spacecraft moving for a longer time than the crew does due to time dilation. Formulas. The formulas shown were used to find time dilation and realistic distance, which is how far the spacecraft travels in a given time. Solving the time dilation problem. Step 1. Dilated time. Substituting the values into the formula gives an outside observer time of 18.98 seconds, almost twice what the crew experiences. Step 2. Distance in the crew's frame. From the crew's perspective, the spacecraft travels 2.55 times 10 to the power 9 meters. This seems shorter because their time runs more slowly. Step 3. Distance in the observer's frame. For the outside observer, the spacecraft travels 4.82 times 10 to the power 9 meters, which is longer because more time passes for them. Are these results realistic? Yes and no. The time dilation calculations are realistic. At 0.85 c, outside observers truly experience much more time than the crew. However, the movie exaggerates the visual effects. Brand's hand wouldn't stretch or move in dramatic slow motion. People inside the fast-moving frame do not visually notice time dilation. And while the third diagram shows different distances measured by different observers, the movie does not depict this correctly. A more realistic portrayal would show that much more time and distance passes for observers outside the wormhole compared to the Endurance crew.